before moving into today's topic, we need to commit our ways unto God, and we want God to teach us and lead us aright. So today we'll be moving on indices. So under indices, rules of indices. So now looking at these rules, so looking at this different and the same base, but what different power. So this is called power. This is called base. This is power, or you can call it exponential, or you can call it index, or power. So this is base. Now indices says the same base but different power. So indices says when they are in the same base, you pick one a, then different power, the times turns to what? Plus for the power. So the same thing applies to the okay, the same thing for the base, the same base, but you pick one a and different power. This divide tends to what? Minus. So 5 minus 3, so this divide tends to minus, this times turns to plus. Now moving to the third one, the third rule says that a raised to power 3 square, you can also you can multiply that 3 times 2, since it is times, or you say a raised to power 3 in 2 places. If it is raised to power 3 in a raised to power 3 in 3 places, so you guys must know, you must know that. So meaning that a raised to power 2 in 2 places, a raised to power 3 in 2 places. So, or you say 3 times this, that's 6. So moving to the fourth rule, the fourth rule says that, and looking at this is different to the one we just treated. To the above, to the rule 1 and rule 2. So looking at this, different base but the same power. So in this it says the same power, you pick one or the other part, and you divide it. A divided by b it is still a divided by b. So now you pick it as 1, and this says you pick it, you take it, you pick 1m. So looking at this is true. The sixth rule says that anything raised per 0, if it is 3 raised per 0, any number, any alphabet raised to power 0, it is equals to 1. So you guys must know that. Now looking to the checking the rule 7. The rule 7 says that a raised per minus 1, it may be in this form, 3 raised per minus 1. This raised per minus, this minus sign will turn to 1 over. And then your 3, when this has turns to 1 over, so what's left? That's 3 raised per 1. So that's it. So the same thing applies to this. A raised per minus 1, this thing turns to 1 over. So what's left? That's a raised per 1. So that is how we got that. Now today we'll be moving on. We'll solve some question that you will surely use these rules we just listed. So let's move into the question. Moving to the question moving to the question. So looking at the question, this is the question. So I want you guys to take note of something. We've treated this rule 2 times 3, or you say, so let's write it out. 6 raised per 3, and you can say 2 times 3, that's times 2 times 3 is 6 times, and divided by 6 raised per 5, divided by 2 times 2 raised per 3. So in this it says the same base but different power. So you pick one, then times turns to plus. So 3, meaning that 3 plus 6, this, okay, 3 plus 6, I that's 9. This divide turns to what? Minus. So minus 5, divided by, you pick one, the same base but different power. So note that there is 1 here, so you must know that 2 raised per 1 equals to 2. So you pick 1, 2, then 1 plus 3. So what will be our final answer now? Okay, before getting to our final answer, 9 minus 5, that's 4, divided by 2 raised power 4. So I want you guys to take note, the same power but different base. So you divide it, 6 divided by 2, that's 6 divided by 2, that's 3 raised power 4. So you pick 1, 4. So you must know that that's the final answer. Now moving to the second question. The second question says, looking at this, 1 over 2 raised per 0. I said it's anything raised per 0 equals to 1. So that is the final answer. Now moving to the third one. The third question says that 4 divided by 25 raised per. So looking at this, turns to 1 over, then 4 divided by 25. So take notes, I said it. So when this has already turns to 1 over, so what's left? Meaning that this is left, raised power what? 3 over 2. So let's solve that. Now looking at this question, meaning that what can I raise? Okay, 1 over, what can I raise into what can I raise that, what base can I raise to power 2? eh? Because of these two. And what base can I raise to power 2? You must know that if I raise 2 as the base raised to power 2, eh? Meaning that times 3 over 2 divided by this 3 over 2 is for both. So you must know that. Eh? Then what can I raise? That's 5 square B will give me 25. So also times 3 over 2 is for both. This 3 over 2 is for both this and this. So these two cancel these two. Equals to 1 over, then also these two cancel these two, so you must know that that's 2 raised power 3, that's 8, divided by 5 raised power 3. I think that's 5 times 5 times 5, 5 times 5 times 5, so that's 125. So 125. So this one, you must know, I want you to identify this, that these two are together, right from the question, but this we inserted it ourselves. So you must know that, I want you to take note that they are, so you will split them. You have to split it. So 1 divided by, so this divide, you put it yourself. So it will now be 8 divided by 125. So equals to this 1 times, so reciprocal of 8 divided by 125, meaning that divide will turn to what? Times. So immediately it turns to 5, this 125 will comes up and this goes down, so it will be 125 divided by 8. So 1 times 125, that's 125 over 8. So that is our final answer. Looking at this fourth question, the fourth question says, so I want you to take note of this. This is it. The base here is 25, the base here is 5, so we need to put it in the same base. We can raise this, so you can raise it to 5 raised power 2, that's 25. 5 squared is 25. So you put this into brackets, 3n plus 2, so times 5. You must know that there is 1, meaning that 5 raised power 1 is 5. So looking at this also, 5 raised power 2 plus 5, then times, we want to raise it in order to be in the same base, so we want to put it in the same base, so we can use the rules of indices. So this will be 5 raised power 3. You must know that 5 times 5 times 5, that's 5, 125. I mean, sorry, it is 5, yes, 5 raised power 3 in your, into brackets, your n, this is n. So looking at this question now, so you pick 5 right from our first rule, and 2 times, okay, before that, yes, you can say 2 times 3, that's 5 raised power 6n plus 4, times 5 raised power 1 divided by 5 raised power 2n plus 5 times 5 raised power 3 times n, that's 3n. So you pick 5 indices. So then your power, this times turns to what? Plus for the power. So 6n plus 4, that's plus 1. 6n plus 4 plus 1 divided by, you pick 5, 2n plus 5 times turns to what? Plus 3n. So 3n, this is 3n. So your final answer will now be, that's 4 plus 1, that's 6n plus 5 divided by 5 raised power 2n plus 3n, that's 5n. So 5n plus 5. So looking at this, you pick 1. So pick 1. Since this is divide, so it turns to what? That's 6n plus 5. This divide tends to minus. So take note, you must put it in bracket because the minus will affect some things. So 5n plus 5. So 5, it will now be 6n plus 5. You minus times plus, there is invisible plus here, so that's minus 5n. Minus times plus, minus 5n. So you take notes, you must put it in brackets next time. In any question you are solving in situation like this, so raised by 5, that's 6n minus 5n minus another 5. No, this is not carrying n. Minus times plus minus times, this is only 5, ordinary 5. So 6n minus n, that's n, then plus 5 minus 5, that cancel each other. So that's our final answer. Looking at this fifth question, 16 raised by x equals to 0.125. So this 0.125, just carry your point. I hope you guys know standard form. So standard form, this point, we want to pick it to this, we want to put it outside here. So 1, 2, 3, we the movement is three times. That's three times. That's 1 2 5. That is 1 2 3. So 1 2 5. The point is outside there. So times 10 raised power. Since we move it to our right hand side, so it will be minus 3. So 16 raised per x equals to 125 times, I said it in our rule, so you can go back and check it. This thing turns to what? 1 over, then what's left? That's 10 raised to power 3. So you can put it back. So 16 raised per x equals to 125 times 1, that's 125 divided by 10 raised power 3. So it will now be x raised per this equals to, what can I raise? Since we can never get the same base, so I want you to take note of this, that the power we can, this is already in raising over 3. The power is 3, and we want to also put this in the power, I mean, to put the power 3, that is to be raising the power 3. So you must know that 5 raised power 3 over 10 raised power 3, that is, we want to put it in the same power but different base. So 16 raised power x equals to, so indices says you divide abi 5 here 1, 5 here 2, that's 1 over 2. 1 over 2, then you pick 1 3. So we want to look for our x abi. So looking at this, this 3 is for both numerator and the denominator. So 1 raised per 3 is 1, then 2 raised per 3 is 8. So looking at this, what can I want to put it in the same base? We can never get this doesn't have power, so we need to put it in the same base. So putting it in the same base, it will be, what can I raise, what can I put, what base can I use in order to get the same base? That you must know that that's 2 raised power 4. So 2 raised power 4 will give us what? 16 abi. So your x into bracket equals to, then 2 raised power, this division turns to minus, then 3. So you can also return it. That's, this thing turns to 1 over, then what's left? That's 2 raised power 3, that's 8. So 1 over 8. So have you seen it? So return, okay, so return it back. So have you seen it? They're already in the same base. So you just say divide both sides by the coefficient, divide both sides by the base, I mean. So when you divide both sides by the base, it will now be divided by 2, divided by 2, 2 cancel 2, 2 this cancel this cancel this, what's left? That's 4 times s, that's 4s equals to minus 3. So divide both sides by 4. So what's left? X equals to what? Minus 3 over 4. Final answer. So looking at this sixth question, so I want you to take note of this, that in our rules we only prove that we only listed the reasons, I mean, like times, divide, division and times, but this is plus the base, I mean. So this is plus. You'll be wondering that, okay, what can I, so don't worry, let's move into this. So looking at this question, so you now see, you are seeing something like 5 5, then plus, so you don't know what to do, so don't worry. So looking at this, you now see, let, so when something is in plus or minus like this, not times, so that you can raise, so when something is in this form like plus, minus, something like this, so you now say let 5 raised power x equals to y. So meaning that you can say 5 raised power x times 2, that's s times 2, that's 2s, plus 1. Or you can also say, I want you to take note of this, 5 raised power 0 is equals to 1 abi. You can also put it like 5 raised power, okay, let's put our 1, put your 1 there, so equals to 26. That's 5 raised power x, that's, you can 5 raised power x, this minus, for the base it will be divided, 5 raised power 1. So if you want to return it, pick 1, right from our rule, so it will be x minus 1. So have you seen it? So they are like, so let's solve that further. So put it in that form. So it will now be 5 raised by x we've assumed to be y, that's y, then put your square on it, then plus 1 equals to 26 open bracket. So you pick 1 abi. So when you pick you don't need to pick one. So since we've assumed that let's our 5 raised power x equals to y, so you just put your y up here over 5 raised power 1. So y square plus 1 equals to 26 times y, that's 26y divided by 5 raised by 1. So you multiply all side by 5, multiply this side by 5, multiply this side all by sides by 5, I mean. So 5 times y, that's 5y square plus 5 times 1, that's 5 times 1 is 5 equals to 26y over 5 times 5. You also multiply this by 5, so 5 cancel 5, so 5y square plus 5 equals to 26y. So I want you to take note of this. We arrive at quadratic equation. So let us solve it quadratically. So looking at this, 5y square, so we want to arrange plus 26 comes in, turns to what? Minus 26y, then plus 5. So using the factorization method, so let's quickly solve that. So using the factorization method, so 5y square times 5, that's 25y square. Now two numbers we can use, in order we can multiply, we can go. So we look for two numbers, we can times and get 25y square. Since first step is to multiply this times this, that's 5y square times 5, that's 25y square. So two numbers we can multiply to get 25y square, that's 25 times, that's, note, it must be, the numbers must be in y, they must be possessing y. So 25 times 1, that's 25y times 25, 25y times y equals to 25y square. So when we add it, we must get this. So when we add the number, the two numbers we got, so we must get this. So meaning that minus 25y plus minus y, so minus 25y plus times minus, that's minus, equals to minus 26. So we place this instead of minus 26y, minus 26y, so we substitute this into it, 5y square minus 25y minus, minus 25. So minus 25 minus y, then your plus 5, so equals to 0. So looking at it, so we need to put it in brackets since we've substituted it, our minus 26y. So we 1 2 3 4, so you must know, you pick it 2 2 1 2. So what's left? Minus is at the center. So what's common? That is 5 can go in 5, 5 can go, so 5 is common, and then y, we have one y, then pick one y. So 5y squared divided by 5y, 5y squared divided by 5y, that's y. 5y squared divided by 5y. So 5 cancel 5, 1 y cancel y, so what's left? 5. 25y divided by this, that's 5. So I want you to take note of this. Whatsoever you get here must be the same thing you must get here. So if there is difference, you must, if there is a difference in the at this point, okay, let's solve it. So looking at this, what's common? So nothing is common, but I want you to take note that 1 times y, that's 1 times y plus 5 times y, 5 times 1, so you must know that 1 is common. 1 times y, that's y. 5 times 1, that's 5. So 1 is common, minus 1, so there is invisible 1 there, but you must know that. So y minus times plus, that's minus, then equals to 0. So have you seen that they are alike? So if they are not alike, you must know that there is a mistake in the question. So let's solve it. So in this is quadratic equation, we have to take one of these. Either you want to take this or this. So we pick one and take this two outer one. So we pick one of this, then 5y minus 1. So since we've gotten that, equals to 0, so we need to look for our y. So we split it, so we split it, this equals to 0 and this also equals to 0, so equals to 0, and then 5y minus 1 equals to 0, and so y equals to plus 5 coming out equals to 5, and so we collect like names at this side also. 5y equals to minus 1 coming to this side turns to 1, 0 plus 1 means 1, so divide both sides by 5, so 5 cancel 5, that's 5. Y equals to 1 over 5 for this side, and at this side y equals to 5. So right from our question, we said let y equals to what? 5 raised power x. So you now say when y equals to 5, so put your, instead of this, substitute, instead of putting your y there, put your 5. So substitute 5 in the situation of y. So that's 5 equals to 5 raised power x. So you divide, you must know that this is raised power 1, 5 raised power 1 is 5, so divide both sides by 5. So cancel, 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 cancel. So x equals to what? 1. You now say, and when when y equals to this, abi, so when our x, let x equals to this, so you substitute also 1 over 5 into this, abi, so that will be 1 over 5 equals to 5 raised power x. So you now say, I want you to take note of this. This divided by 1 over means 5 raised power minus 1 equals to 5 raised power x. So you divide both sides by 5 also. So when you divide both sides by 5, 5 cancel 5, 5, so x equals to minus 1. So those are the two answers of x, and those are the two answers, x equals to 1 and x equals to minus 1. So thank you and God bless you. I hope you guys understood this lesson, and if you have any question on this, I want you to comment me on the comment text message. So thank you and God bless you. So remember to subscribe. Thank you.